this episode, we're going to connect a set of Git ideas that beginners often learn as separate commands into one clean story. How a change moves from your laptop into the shared history the team depends on. That journey is the commit life cycle, and it matters because most mistakes in collaborative automation work are not about writing the wrong code, but about losing track of where the code currently lives and what state it is in. When you understand the life cycle, you stop treating Git as a black box and start treating it like a predictable system with distinct stages. Those stages exist to give you control, because control is what prevents accidental breakage and confusing coordination failures. Automation work needs that control because automation is deployed and executed repeatedly, and the shared repository is often treated as the authoritative record of what is safe. If you can follow a change from the moment you type it to the moment it becomes shared truth, you can work faster with less fear and fewer surprises. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Everything begins in the working tree, which is the set of files on disk that you can open, edit, and save. The working tree is where you experiment and iterate, and it is intentionally flexible because learning and building require room for trial and error. Git watches the working tree by comparing it to the last recorded snapshot, but it does not record changes automatically just because you saved a file. This is a crucial beginner concept. Saving is not committing, and committing is not sharing. The working tree is your private workspace, and you can make changes there that are messy, incomplete, or exploratory without forcing them into the project's permanent record. That separation is one of Git's greatest strengths because it lets you work naturally without constantly worrying that every keystroke becomes history. For deployable automation, the working tree is where you shape ideas safely before you ask the rest of the team to rely on them. Between the working tree and the project history sits the staging area, sometimes called the index, which is where you decide what you are about to record. The staging area exists because your working session might contain multiple kinds of edits, and you often want to commit them as separate logical changes. Beginners sometimes think staging is an unnecessary extra step, but it is actually the mechanism that lets you craft clear, reviewable commits. You can treat the staging area like a packaging table, where you lay out exactly what belongs in the next snapshot. This matters in automation because clean commits reduce troubleshooting time later. If an automation behavior changes unexpectedly, it is much easier to identify the cause when commits are focused and intentional. The staging step is where you turn raw editing activity into a coherent unit of change, and that coherence is one of the main ways Git helps teams stay organized under pressure. Once changes are staged, committing creates a permanent snapshot in your local repository along with metadata that describes it. A commit records what the project looks like at that moment, and it includes a message, an author identity, and a link to its parent commit. Beginners often imagine a commit as storing just the changed lines, but conceptually it is safer to think of it as a full-state snapshot that Git can reconstruct efficiently. That snapshot becomes part of your local history, which means you can refer back to it, compare it, and even restore it later. A local commit does not automatically affect anyone else, and that is a feature, not a limitation. It lets you build a series of checkpoints that document your progress, even if you are not ready to share yet. For deployable automation, local commits act like a lab notebook, capturing decisions and allowing rollback if an experiment turns out to be wrong. At this stage, the change is recorded, but it is still private to your local repository. That is where the life cycle often confuses beginners, because the word commit sounds final. In Git, commit is final in the sense that it is part of your history, but it is not final in the sense that it has become shared truth. Shared history is the set of commits that exist in the remote repository the team uses as a reference point. The remote repository is where coordination happens, and it is often connected to processes like review, testing pipelines, and deployments. To move a local commit into shared history, you push it to the remote, which is an explicit act of publication. This distinction protects teams because it prevents accidental sharing of incomplete work. It also gives you a clear checkpoint where you can stop and ask, is this ready for others to see and build on? Before you push, you often need to synchronize with the remote to avoid conflicts and confusion. The remote can change while you are working because other people are committing and pushing their work too. Fetching updates your view of the remote state without changing your current branch, while pulling both fetches and integrates. The important life cycle point is that shared history is not static, so your local commits exist in a moving world. If you push without awareness of the remote's current state, you might encounter rejections or, worse, create integration problems that others have to resolve. A mature approach is to treat synchronization as part of the commit life cycle. You record locally, you update your view of the shared truth, you integrate changes if needed, and then you publish. This rhythm reduces surprise because you are aligning your work with the team's current baseline before you ask others to accept it. When you do push, you are sending your commits to the remote and updating the remote branch pointer to include them. At that moment, your commits become available to teammates, and they may trigger automated actions like builds or checks. This is where commit quality matters because pushing is not just sharing code. It is potentially activating processes that treat the code as an input. In automation-focused repositories, those processes might include validation steps or packaging for release candidates. If you push a commit that breaks the build, you disrupt the team's ability to integrate and deliver. This is why the life cycle includes responsibility. The act of making something part of shared history should align with the team's expectations about stability and readiness. Beginners sometimes see this as gatekeeping, but it is really about protecting the shared workspace, because the shared workspace is what everyone depends on. Once commits are in shared history, they become part of the project's collaborative narrative. They can be reviewed, referenced, and included in releases, which means the commit life cycle continues beyond the push. A commit might be merged into a stable branch, included in a tagged release, or rolled back if it introduces issues. Shared history is also what incident responders use when something goes wrong, because it is the record of what changes could have affected a system. This is where your earlier choices about staging and commit messages pay dividends. A well-crafted commit makes it easier for others to understand what changed and why, which reduces the chance of incorrect fixes under stress. In deployable automation, the ability to reason about history quickly is a form of resilience, because it helps teams recover from errors without introducing additional ones. It's also important to understand how the commit life cycle interacts with branching, because commits do not exist in isolation, they live on branches. A commit on a feature branch might be shared for review without being part of the stable line. That means shared history can include work that is not yet release-ready, and branch context is what tells you how to interpret it. This is why branch naming conventions and release strategies matter. They provide the map that explains which commits are candidates for deployment. If you confuse a feature branch with a release branch, you might deploy the wrong code, even though everything is technically in the remote. The lifecycle, therefore, includes not just the movement of commits, but the meaning of where they land. Beginners often focus on the mechanics and miss the semantics, but in automation work, semantics are what prevent operational mistakes. A subtle but powerful aspect of the commit lifecycle is that it supports learning and accountability without punishing mistakes. Because you can commit locally and keep history private until you are ready, you can experiment safely. Because shared history is explicit and reviewable, you can collaborate and improve together. And because history is durable, you can trace changes during troubleshooting and understand what happened when. This system only works well when people respect the stages and avoid shortcuts that blur them. If you skip staging, you may create messy commits that hide intent. If you skip synchronization, you may create avoidable conflicts. If you push impulsively, you may disrupt the shared workflow. Understanding the life cycle helps you avoid these traps because you can see the consequences of each stage clearly. For beginners, one of the most common misunderstandings is thinking that Git exists primarily to prevent mistakes, when in reality, Git exists to make mistakes recoverable and collaboration manageable. The commit lifecycle is a structure that gives you multiple points to check yourself before you publish changes. You can examine the working tree before staging, inspect the staged snapshot before committing, review commits locally before pushing, and confirm remote state before integrating. Each checkpoint is an opportunity to catch errors early when they are cheap to fix. This matters for deployable automation because the cost of an error can grow quickly once it reaches shared history and becomes part of a release or deployment. The life cycle is therefore not bureaucracy. It is a cost control mechanism that keeps mistakes small and recoveries fast. To bring it all together, the commit life cycle moves from working tree edits, to stage selections, to local commits, to synchronized integration with the remote, and finally to publication into shared history. Each stage exists to give you control, clarity, and the ability to collaborate without constantly stepping on each other's work. When you respect these stages, you create cleaner commits, fewer conflicts, and a more trustworthy shared record, which directly supports predictable delivery and incident response. In automation work, that trust is essential because systems often execute what the repository contains without asking permission each time. When you understand how changes become shared truth, you can manage that truth intentionally rather than accidentally. That is what it means to move from being someone who uses Git to being someone who uses Git well.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.